Getting Away with Murder, The Probability of Clue.
By Gianna Cassio and Elia Bortolucci.
Game concept. Clue is a classic board game where playing solve a murder mystery. By moving around the board to collect clues, players aim to accomplish the goal of figuring out who committed the murder, with what weapon, and in which room.
Rules setup. Randomly select the following cards. 1 suspect card, 1 weapon card, 1 room card. Place these cards into the envelope without looking. Then decide who goes first. Everyone rolls the dice and the highest roller goes first. The play then continues left. Rules in play. Roll the dice and move your character token that number of spaces around the board. You can move vertically and horizontally, forward and backward, through the corridor, but not diagonally. Always try to enter a room. You don't need an exact roll to enter. If your roll would have taken you beyond the room, just finish your move early and stop in that room. If you enter a room, you must stop and ask a clue question about 1 suspect, 1 weapon, and the room you think the murder must have taken place in. For example, you can say, was it Scarlet with the rope in the garage? The player on your left must be the first to try to answer your question. If they have any of the cards you asked about, they must show one of them to you secretly. If they don't have any of the cards you asked about, they just say, I cannot answer, and the question passes to the left to the next player, and so on until you have shown 1 card.
Rules. Conclusions. Cross off the card you have been shown on your clue sheet. It's not in the envelope, so it's not involved with the murder. Leave the character and weapon token you moved where they are. If the character token you moved belongs to another player, they can ask a question on their next turn without moving. Now, your turn is over. No matter who answered your question, the player on your left goes next.
Elements of probability. The initial setup of the game. In the initial setup of the game, the cards are randomly distributed amongst players. As the game progresses, the likelihood of a particular suspect, weapon, or room being a part of the winning cards changes based on the information gradually revealed throughout the game. The probability of the number of outcomes. There are 324 ways of winning. There are 6 suspects times 6 weapons times 9 rooms, which equals 324 different situation outcomes. So therefore, the probability of a specific scenario is 1 over 324.
Elements of probability. Weapons. There are 6 weapons, so P, specific weapon, is 1 over 6. Suspects. There are also 6 suspects, so P, specific suspects, equals 1/6. Rooms. There are 9 rooms, so P, specific rooms, equals 1/9.
So here's our experimental data, and we did this based off 20 games. So the first element of chance we did was based on all of the weapons. So after 20 rounds, we concluded that the candlestick was the murder weapon 6 times, the wrench was 1 time, lead pipe 3, rope, and the dagger were 4, and the revolver was twice. For our second element of chance, we did the rooms. Out of the 20 games, this is the data that we collected. So twice it was in the hall, 1 time it was in the study, twice in the ballroom, 4 times in the billiards room, 1 time in the dining room, 3 times in the kitchen and the lounge, twice in the conservatory, and twice in the library. And then for our third element of chance were our suspects. So twice Professor Plum did it, 4 times Miss Scarlet did it, 3 times Colonel Mustard did it, 7 times Mrs. Peacock did it, 3 times Mr. Green did it, and the 1 time Dr. Orchid did it.
Data analysis. 2 elements of clue. Element 1. Selection of the murder scenario. The murder scenario consists of 1 suspect, 1 weapon, and 1 room. Typically, there are 6 suspects, 6 weapons, and 9 rooms. The total number of murder scenarios is 324. Each scenario is equally likely, so the probability of any specific scenario being chosen is P, specific scenario, 1 over 324.
Number of players. Assume there are n players. The 18 remaining cards are dealt as evenly as possible among those players. If the number of players does not divide evenly into 18, some players will receive 1 more card than the others. For example, there are 4 players. Each player gets 4 cards, 18 divided by 4. There are 18 minus 4 times 4, which equals 2 cards remaining. Therefore, 2 players will get an additional card.
Probability distribution analysis. The probability the probability distribution for a player holding any specific card depends on the total number of cards each player has. If players have an equal number of cards, the probability is straightforward. If not, we need to consider the slight difference in probability due to the extra cards. For n players, P, holding a specific card, equals number of cards the player has divided by 18. For example, with 4 players, 2 players with 5 cards, and 2 players with 4 cards. First, we would do for 5 cards, P, holding a specific card, equals 5 divided by 18. For 4 cards, we would do P, holding a specific card, equals 4 over 18. Conclusion: theoretical versus experimental probability. In the game Clue, the theoretical probability states that for each element of chance, weapons, suspect, and room, they are equally likely and have a 1 over 6 or 1 over 9 chance of being drawn and placed into the envelope. To fulfill the murder scenario, however, after collecting data firsthand, it was evident that the results were not equal to 1 over 6 or 1 over 9. They were instead more like 3 over 10, 1 over 10, or 3 over 10, 1 over 20, 1 over 5, or 1 over 10. In conclusion, the theoretical probability is not equal to the experimental probability.
Elements of chance affecting strategy. A solid understanding of probability allows Clue players to make more informed decisions, strategically both the enjoyment and competitiveness of the game, while elements of chance play a role in the cards dealt. However, increased levels of experience allow for a better understanding of how to maneuver and manipulate elements of the game in order to win.
So now we have the conclusion where we provide insight on the differences of chance versus skill throughout the game. So for the elements of chance, we have the initial distribution of the suspect, weapon, and room cards that are put into the solution envelope, and then the sequence of turns and the cards each player holds, and then also choosing whom to ask and what combination of suspect, weapon, and room to suggest.
And now for the elements of skill. Players need to use deductive reasoning skills in order to interpret the random setup and which way to proceed. Effective questioning strategies and observation of the questions others ask. Skilled players know which questions to ask in order to maximize the information gained in each round.
And that's everything. Thank you.
The end.